This video is an introduction to CAMplete Lite, which is a 3-axis post-processing and collision checking tool for 3-axis machines. I'm using Mastercam MIL-X9 for a 3-axis project. I'm going to import into a RoboDrill using CAMplete Lite. We have a plugin available for our advanced application for 5-axis. I'm going to use that same application so I can grab the fixture, part, and tooling and just simply select one file and have it bring it all into the project. Select my part first and provide a name. Select my geometry for my fixture second. Provide a name. I've loaded CAMplete TruePath Lite. Going to select the project file, which was created from the CAMplete plugin from Mastercam. This will automatically load the part geometry, fixture geometry, tool holders, and the cutter location files for that project I exported. When I first start CAMplete TruePath Lite, it wants to know which 3-axis machine I wish to post to. By selecting it, automatically applies a formatter, and it loads any tool holders if they were part of the file that you loaded. I have a 2D and a 3D view. Once you say finish, it applies a formatter, loads the machine, and shows you the G code for that program. Once you load the initial data, we're ready to simulate and collision check. We have some collision checking tools up here for warning or stopping. Proximity checking tools for checking for close calls with tool holders and fixtures. If anything gets within the distance you specify here, you can have it stop. Or overcuts. Overcuts are the allowable deviation that the cutting edge is allowed to touch the model. I'm going to turn that on and set this value to 0.010 of an inch, and that's going to check for any type of cutting edge interference between the model by 0.010 of an inch. You can see it's simulating the G code here. And it's doing some helical motion there, and I can clearly see that it's cutting into the part. And so TruePath is recording these warnings and telling us that there are overcuts in this project. I see it for both the helical motion and these drilled holes. Now I've gone back to the CAM system to see why I have these overcuts, and when I go back to that helical operation and simulate it, I can clearly see that the tool is cutting into the model. Now let's take a look at the peck drilling operation that was reporting overcuts in Mastercam. I'll put it to a front view and zoom in here and simulate it to see where it's actually drilling. Now in Mastercam, the part geometry has a flat bottom, but when we program the drill, it's going to go past this point, and that's why it's reporting this as an overcut. Once you have your project all posted and you're satisfied with the output, you can create a setup sheet that you can manipulate and customize with a header and footer for your company. You can export it in a couple different formats. I'm going to select a PDF file, which will take a snapshot of the setup and provide a visual reference for the operator when he gets the job, from the tooling to fixturing to parts.